Okay, so I kind of forgot to use colors. So let me just check if the count. Yeah, Microsoft's on. So matrices take vectors from one vector space to another vector space, and I wasn't really clear what a vector space was. I don't think I said. I think I did say in the first video that I will explain them. Now I'm going to explain them. So a vector space. A vector space is something where there's things, we can add them, and we can multiply them by numbers, as in field elements, like real numbers, for example. So we pick a field, and we can add vectors together and multiply by elements in that field, okay? To write it down, like, that's basically all there is to it. That's what a vector space is. So we can add vectors and we can multiply them by something. But to write it down, if we say U and V are in a vector space V, then, so if, then U plus V is in the vector space, and A times V, sorry, oh, I should use colors, okay, so I'm going to make all the vectors blue. Right, alright, that's a rubber. U, V, U, V, U, and V. And I'm going to make the scalars yellow, because why not? In fact, it's just the field elements, so I haven't called them scalars. There we go. So, for example, so there's a lot of things you can say about vectors fields, and I found prove all of them. But first of all, we can say, so we say, and also I need to tell you what A is. So oh damn, where A is an element of some field. I mean, I would like to say it's real numbers, but you know, I'm in university and they say, you know, it should just be abstract, it's fudging impossible, so so yeah, so we can add them and scale them by some field element. Okay, so we've got that much. So basically, just to make some sort of, vectors can be very abstract. It could just be literally functions even. So the vectors I'm talking about are finite dimensional vectors. Finite dimensional vectors that have, so column vectors. So in other words, the vector, the vectors I'm talking about can be written out like, so very yellow for numbers. Say U1, U2, up to UN, where these U's are numbers, and that would be equal to U, the vector. Oh damn, the U, the vector, okay? So let me just put a little easy peasy. Okay, well that's pretty nice. I should just do that again. So, oh, and I should say we write vector fields over the field like this. At least I've seen someone do that. So there we go. So this is what we mean when we say it's a vector field over F. Okie dokie. So here's some things. So we know 0, there's a 0 in the vector field. And what 0 does is if we do 0 plus something u, let's say, so we said u is in the vector field. 0 plus u is equal to u plus 0 is equal to u. Okay. Also, we know that 0, as in the field. Okay, so we should put a little. I'm gonna put a little underline if the zeros are vectors. In fact, no. Okay, so I'm gonna put a little vector symbol. If the zero, this 0 over here, this is just a number 0. Okay, so if you multiply the u, so this is every field has a 0, and this is the 0 I'm talking about. So if you do 0 times u, then you get the 0 vector. So if you multiply a vector by 0, the number 0, then you get the 0 vector. You should also say, that's very nice. Actually, I should put these two together in one box. And there should be like a there exists here, such that. And also, and obviously you can have a go at proving these are true if you want. It's up to you. It's not that difficult. I mean, at least it shouldn't be. And also there's some other things that I can't think of at the moment. And I mean, I'm not entirely sure, but something like this, for example. So distributivity and stuff like that. I mean, all these things, DIST, oh damn, you know what, look, anyway, so all these things we should just keep in, like, these are things that kind of are obvious, but sometimes they're just, like, not. What I mean by that is, for example, in this one, if you don't know how to prove it, you just use distributivity, and that's how you do it. But that's not quite. It's not quite obvious, but that's just how it is. So that's basically it. I think I spent way too long trying to explain this, but basically, vector space is just this. I think I said that twice at the start, and you could have just stopped then. But yeah, that's all a vector space is. And we'll be looking at different vector spaces associated with a matrix in the next video. Oh, yeah, okay. So see ya, and thanks for watching.